All right, we have our second day this week, which is rational equations, right? So yesterday was expressions with fractions. Today's going to be equations. You can see this. I think these ones for us should be hopefully pretty easy. You have two fractions equal to each other. You can just cross multiply here. You'd get 7x equals 32, and then you divide by 7. You get 32 sevenths done. So when you see ones like this, right, that may be a little more complicated, like don't feel like you have to get a common denominator. It's different with equations. You can literally just cross multiply. Just always use parentheses, then you won't really get stuck. And then you go from there. So I'm not going to do this one out, but again, you could just cross multiply here and get your answer there. You do want to check your answers to make sure that they fit. There is a possibility for extraneous answers with this lesson. And we may do one today or maybe showing up on one of the practice problems, but it could happen. This is the ones really for the lesson, right? So it's a matter of, you have this number which may or may not have a denominator, but, when you have one side of the equation, you may be better off trying to find a common denominator or at least trying to get rid of your denominators. There's really two ways you can do this, and you have freedom, right? You can move parts around if you want to get it to something that you want to work with, but you really have some freedom, right? So I'm going to show it to you one way, and this way is just going to be, well, I'm just going to take care of my denominators step by step. So you can't just multiply one side by something with an equation. It has to be balanced, right? So we're going to multiply the left side and the right side by x plus 7. And what I'm basically doing is trying to get rid of my denominators one by one. So on the left side, if I take x plus 7 and I multiply it by 12 over x plus 7, these x plus 7's cancel, and I just get 12. Now on the right side, it actually makes it more complicated. I have to distribute this to both terms. So x plus 7 times 1 is going to be x plus 7. And then I have minus, and then these x's don't cancel. It's just going to be 12 times x plus 7 over x, right? And so now I kind of have this, which almost maybe seems more complicated, but I still have a denominator here, which I'm going to try and get rid of. So, I mean, you can distribute these out if you want to. Sometimes it's good to keep them together and see if something factors out. It won't here. But I'm going to basically now take my left and right side and multiply both sides by x so that I can get rid of this denominator here. So on the left side, 12 times x is just 12x. On the right side, again, I have to distribute it to this, right? So that's going to be x squared plus 7x. And then this one as well, but this one's not so bad because the x's will just cancel, and I'll get my minus, 12 times x plus 7. And then, from here, I don't have any denominators. I don't have to worry about too much. I do see an x squared, so I'm going to get everything onto one side. So I'm going to say, 12x equals x squared plus 7x. This is all combined. So I'm going to say minus 12x. And then it's going to be minus, because I want to distribute this negative to the 7. And then 12 times 7 is going to be 84. So now I'm going to get it all to one side. So I got 0 equals x squared. Now I have a 7x minus 12x. That's negative 5x. And then I'm going to subtract 12 more from this side. So it's going to give me actually negative 5 minus 12 is going to be minus 17x. And then minus 84. And lo and behold, this does factor, right? It's going to be 21 times 4 is going to give us 84. So it's going to be negative 21, and it's going to be the positive 4. And so I get two values of x. I'm going to say x is going to equal two different possibilities. X could equal 21, and x could also equal negative 4. And what you want to check for extraneous is you could check by plugging them in. That's a little bit trickier. Really what we're doing, guys, is these two answers, just make sure that they don't create 0 in the denominator, and you'll be okay. So if I got negative 7 or 0 here, I would have to cross them out. Obviously, 21 plus 7 is fine, and 21 is fine. Negative 4 plus 7 and negative 4 are fine. I don't get 0 in the denominator. That's really what you're checking for extraneous. And for this one, we see one that looks a little bit trickier. We're going to kind of attack it the same way. We have, it looks like 3 different denominators. Again, anytime you see something that's in standard polynomial form, I would always try and factor it out. And so I would look at this and say, I'm going to write it as x plus 3, x minus 3. And it breaks down to conjugates, and then you see it kind of matches these, so it's not as bad a problem. So again, if we just want to try and get rid of the denominators so that we don't have to deal with them, just pick one, either x minus 3 or x plus 3, and multiply both sides by it. So I'm going to take x minus 3 and do that first. And I'm going to multiply it by the right side as well. And we'll see what we get. So we have x minus 3 times 6 over x minus 3. These would cancel, and I would just be left with 6. And then on the right side, again, I would have to distribute this to both. When I distribute it to this term, the x minus 3 and the x minus 3 cancel, so that keeps my life easier. So it's just 8x squared over x plus 3. And then I have minus, and then basically I'm going to need to distribute, like this is going to go to this part. I don't cancel with anything in the denominator, so this gets a little more complicated. It's going to be 4x and then times x minus 3 over x plus 3. And if you wanted to like distribute this out before you wrote it, that's fine. Now I have one denominator left, so I can do 2 things here. I can try it, like they both are like terms at this point, so I think it would be a little bit intuitive of me to like try and combine here and just write it as one fraction, and then I can cross multiply. Let's just say, for example, you didn't see it or it didn't work out that way. We'll take it that way, but again, keep in mind, I can combine these and make my life easier. I'm just going to choose to do it a little harder because sometimes it won't work out this way for you. So I'm going to now multiply both sides by my x plus 3. And, you know, over here I have 6 times x plus 3. So it's going to give me 6x plus 18. And then equals, so when I distribute the x plus 3 here, it cancels with the denominator. It's just 8x squared. And then when I distribute it here, it cancels the denominator. It's just going to be this, which I'm actually going to multiply out now. So minus 4x squared, and then minus negative 12x. So I'm going to say plus 12x. And now I have no more denominators. You see I have a quadratic, so I'm going to get everything to one side. So it's going to give me 0 equals 8x squared, 4x squared. It's going to give me 4x squared. Plus 12x, but keep in mind I'm going to subtract 6x from over here. So it's going to be plus 6x. And then minus 18. And so what I see right away is that each term has 2 in common. So I'm going to divide both sides by 2. 0 divided by 2 is still 0. And I get 2x squared plus 3x minus 9. And that's going to do it. I'm going to hope that this factors, otherwise I'd be stuck with the quadratic formula. I don't think you should expect many of those, but it could happen, I suppose. And so let's see here. If I did 2x minus 3 and then x minus 3, right, this is going to give me 2x. Yeah, I think this works. Or actually, I'm sorry. So I want a 2x. One of these is going to have to be plus 3. So this is going to give me negative 6x minus. So I'm going to do plus 3 here. So that way I get 2x squared. I get plus 6x minus 3x, which is plus 3x, and then minus 9. So my 2 values of x are going to be x equals 3/2 and negative 3. So the real answer is actually only x equals 3/2. And you say, why? Negative 3 is extraneous. Again, mathematically it came out to be an answer. But look at the original equation. I could never plug in negative 3 here or actually here either. I could have plugged it in here, but it doesn't matter. If it doesn't work for one, it's not going to work. So only 3/2 is the answer. This is an extraneous answer, which is why we really look to make sure we don't get 0 in the denominator. That's it. I think I had one partner practice on here. You don't have to worry about it too much. You can do it if you want. There was also an application problem on software. It doesn't really involve too much of what we did. It would just be more of a graphing calculator. one side is equal to 5.3, the other side's this, and find the intersection. So that's it. Go get them.